Hi, so this is the second video for chapter 1, and in this video I want you to talk about some of the topics that I want you to watch out for as you do chapter 1 exercises. So as you do chapter 1 exercises, you will see a bunch of number problems, and it's not because this course is about numbers. It's about physics, and sometimes as you try to understand the physics concept, it'll be sometimes easier for you to think about a numerical example. So that's why I want you to look at some of the measurement questions and have you look at some numerical exercises to get you more comfortable working with the numbers. So measurement questions are something that you will see on the exercises for chapter 1. And the other topic that you will see as you work through chapter 1 exercises are metric prefixes. Metric prefixes. There are a few that I want you to have memorized. I'll write them down here. They are also in the textbook. Some of them you have to know for the homework. So I'll talk about the metric prefixes pretty soon. Oops. Sorry, I'm new to this tablet, so okay. Metric prefixes soon. And the last topic that I want to talk about that you will see as you do chapter 1 exercises is what's sometimes called scaling. So let me just block off some area here to talk about scaling. It's a fun topic. A lot of people don't get this intuitively, so I want to talk about that because I think if you're taking a physics class, I think you should get a good sort of intuition for how area and volume change, and it's not intuitive initially. So, all right, let's talk about this. So when we talk about measurements, the first thing that you should realize, you should be aware of, are units. So there are some basic units that we can talk about. These are called SI units. So in SI units, the three basic things you measure are meter. You use meter to measure a length. Meters almost like a yard. Then kilograms, you use kilograms to measure mass. Kilogram to measure mass. And seconds, you use seconds to measure time. So these are the basic SI units of measurement. And in the exercises, what you will see is more, I guess, unconventional unit of measurement. For example, so I can use a meter to measure distance, or I can use my hand, or in particular, my thumb. So I first have to know how long my thumb is. Let's say I take a ruler, put it against the thumb. If you see that this ruler doesn't have any marks, well, it doesn't, so I'll just make up a number. Let's say my thumb is 5 centimeters long. All right, so my thumb is a unit. One thumb, I know how to convert it to centimeters. One thumb is 5 centimeters. Now I can use this thumb to measure other things, like my cell phone that I got recently. So to measure the length of the cell phone, I take my thumb, okay, one thumb, two thumb, and maybe let's say 2.5 thumb. So I wanted to measure my cell phone length, and I get, I think this color is better. So for my cell phone length, I say it's equal to 2.5 thumbs. So this is my unusual unit of measure. Now, if I say 2.5 thumbs, maybe if some of you are taller, your thumb will probably be longer. So this doesn't really means something standard. So when I'm talking to someone else, I might want to convert this to one of the more standard units, like centimeters. Then, because one thumb is equal to 5 centimeters, at least for me. So when I convert this to centimeters, it becomes 2.5 times 5. So that is 10, 12.5 centimeters. So using my thumb, I measure my cell phone to be about 12.5 centimeters long. Maybe it's a little bit longer than that, but that's the basic idea. So that's the measurements. You can come up with your own units. Usually we stick to meter, kilogram, and seconds in the scientific fields. But you know, every day we are fine using miles, pounds, whatever. Now, metric prefixes are something that's very useful when we are dealing with, well, metric units, like a meter. And knowing these prefixes will help you figure out, well, how big a quantity is. So let me just write down meter as the metric unit that we are talking about. And so you can talk about a meter like I did it before. But usually when we are talking about something that's shorter, we would talk about centimeter as I did before. So there are these prefixes you can put to the meter. Centimeter. There are prefixes that go even shorter than centimeter. There's millimeter. And you can go shorter. There's a micrometer. Micro. You can go even shorter. There's something called a nanometer that we'll talk about sometime throughout the course of the semester. You can also go smaller, picometer, odometer, but people don't usually do that. You can go the other way. You can go to bigger, longer sizes. So from meter, the next one up that we usually talk about is kilometer. And the next one up. Now with the meter, we don't really say this, but we could say megameter, megameter, or gigameter, or terameter. Now, you know, if you ever said to a friend, so I guess from San Francisco to New York, that should be about 2 megameters away. People stare at you weird if you said that. So the other unit of measure that often goes with mega, giga, tera, they are bytes, megabytes, gigabytes, terabytes. So maybe you could be talking about megabytes, gigabytes, or terabytes. But the meaning of the prefixes remain the same. And these are the meanings of the prefixes. What these prefixes tell you are, what are you multiplying to a meter? Some power of 10. So if you have no prefixes, then you're dealing with the numbers that are 10 to the power of 0 or 1. Centimeter, that means that prefix means you are dealing with the 10 to the power of -2. So a centiliter is 0.01 liter. Milli refers to 10 to the -3. And after that, you will see some regular pattern. Micro is 10 to -6. Nano is 10 to -9. Let me go the other way. Kilo is 10 to the 3. Mega is 10 to 6. Giga is 10 to 9. And tera is 10 to 12. Do you see the pattern? Except for centimeter, which is sort of in between. These are powers of 10 in sort of groups of 3. And this is just about all the prefixes. If you know these, you know more than an average starting engineering physics student. At the very minimum, I want you to know what millimeter is and what a kilometer is. And you know, the more you know, the better. But the milli and kilo are pretty close to 0, so you should know those. So those are metric prefixes. There will be some problems in your homework where you have to deal with these metric prefixes. Now let's get to scaling. So here's an example of scaling, sort of comparing two different sizes. So I can compare, for example, 1 meter that we've been talking about to a centimeter. So let me draw a drawing of a meter stick. So here's my meter stick. All right. Here's my meter stick. So this is 1 meter long. The length of this is about 1 meters. Now, usually when you look at a meter stick, it's subdivided into smaller pieces. If you're looking at a meter stick, it's divided into hundreds of these smaller pieces. Each one of this small piece, you might call that, well, you should call that 1 centimeter. And if you keep going along this number of ticks, count them all, then there will be 100 centimeters in 1 meter. Not that surprising. Most of you might know that already. Good. Now, the part that's not as intuitive is the scaling. Okay, so we know scale comparison between a centimeter and a meter. A meter is 100 times as big as a centimeter. Now, let me ask you this question. Suppose you are measuring an area. So let me draw a square that we can measure area of. So here's a square. So I'm going to say this square is 1 meter in length in all the dimensions. Now, it doesn't look as long as the meter stick. I just shrunk it so that it will fit on the screen. All right, so here's a square. And let's say, we want to measure the area of the square. You might remember from geometry, area is length or height times length. That gives you the area. So if I make this square 1 meter in length of all the sides, then the area of this square will be 1. So 1 meter times 1 meter gives you 1 square meter. 1 meter squared. So that's the area of this square. Now, what would its area be if instead of writing it in meters, or meter squared, we expressed it in centimeter squared? Will it be 100 centimeters squared? Well, let's just think through it. So just like with the meter stick, this length is going to be subdivided into smaller pieces. I'll just draw some of these smaller pieces. Imagine each one of these is 1 centimeter long. 1 centimeter. So there's going to be 100 of these. And you can also go this way, dividing into 1 centimeter sized piece. And there's also going to be 100 of these this way. So you can look at one of these squares that's made by these 1 centimeter long side. So look at this one square, for example. Area of this one square is 1 square centimeter. 1 centimeter squared, because it's 1 centimeter on one side, 1 centimeter on the other side. Now, how much of this area would you fill in if you had 100 of these? Now, when you think about it carefully, then you should realize that it won't fill in the whole thing if you only have 100 of these. So here's a 1, 2, 3, keep going. When you have 100 of these, you'll end up right here. So with 100 of these squares, what you will end up filling is just this tiny little strip. Now, any guesses how many of strips there are? 1 centimeter, 1 meter. There's 100 of these along this height. So you have 100 square centimeters here. You have 100 more of these here. So the total number of these little squares you'll need is 100 times 100. You need 10,000 square centimeter pieces to fill in 1 square meter. So this is what I mean by scaling. So going from a centimeter to a meter, that's a scale factor of 100. That's for the length. So the scale that you are seeing here is the scale of length. Now, when you have scale of area, you get the scaling factor squared. Now, if you think you understood this, I want you to work out volume on your own. So here's one good number to know. It's all better for you to be able to work it out as well. So with the volume, if you have 1 cubic meter, how many cubic centimeters do you think that is? If you said 1,000,000 cubic centimeters, you're right. 1 cubic meter, which is a pretty big volume, it's 1,000,000 cubic centimeters or 1,000,000 cc, which stands for cubic centimeter. So that's scaling. This is so some of you might be smart enough to figure this out on your own, but oftentimes people don't think about this that a lot. So when you see this first time, it's unintuitive. A lot of people get it wrong. My hope is that having seen this, you won't get it wrong. So please do the chapter 1 exercises. I will be uploading chapter 2 video pretty soon. Bye.